Hello, welcome to a video. This is going to be the first kind of lesson where you're learning online for 1010. It's Mr. Green here, just doing a few short videos to kind of help you work through this. You can also look in the book as well to get some help. They usually have some pretty good examples in there too. But just in case you learn better by listening and watching, I'm doing this as well as giving you the book there. So today's set of videos are going to be about section 7.3. Which is about simplifying radicals. Okay, so we're going to talk about simplifying radicals and how we do this. The main rule for which we're going to be able to do this, there's really two rules, and they are as follows. The product rule for radicals is as follows. If you take an nth root of a product of two numbers, so remember the little n up here means an nth root of the product of two numbers, that's the same thing as doing the nth root of the first number times the nth root of the second number, okay? So in other words, whenever you're dealing with radicals, anytime you have a root involved, it works really well with multiplication. You can just split up the roots into two separate roots, okay? And then the other rule that you may run into is the quotient rule, okay? And basically, quotient just means division, so that's basically the same, it's just with division instead. So you've got, when you are doing the nth root of a fraction, you can just do the nth root of the top divided by the nth root of the bottom. In other words, roots work really well with multiplication and division. Okay, they don't work so well for addition and subtraction. Similar rules don't work when you have addition and subtraction, but these rules do work because if you kind of think about it, products are multiplication, and the nth root is like kind of undoing repeated multiplication. It undoes the nth power, so it works really well with multiplication and division. So these are the rules that you're going to be using to kind of, and they're kind of going to be happening behind the scenes to be able to simplify these essentially, okay? And I'm just going to do a few really simple examples of simplifying some radicals. This should be semi-familiar to you from your previous math classes, but I'm going to do just a few examples to kind of help you see why these rules are important and how they help us make radicals simple, okay? So for instance, let's look first at the square root of 50, okay? So in this case, my n is 2, right? And so one way that you can simplify this is if you kind of think of what goes into 50, the factors of 50. Well, let's see, we know 2 goes in there, right? Because it's an even number, so I could factor out a 2. So I've got like 2 times, sorry about that, made a mistake. 2 times 25 is 50, right? And so what I could do here is using my product rule. I know when I have a square root of 2 numbers times each other, you can split it into 2 pieces, right? The square root of 2 times the square root of 25. And then you could kind of simplify each of these. The square root of 2 is a nasty number. That isn't too nice. But the square root of 25 is actually quite nice because you can rewrite the square root of 25, or 25. What goes into 25? It's 5 times 5, or 5 squared, right? And so you're thinking, well, square root undoes a square, right? So if I write this instead of 5 times 5, if I write it as 5 squared, the square root and the square cancel out, right? They undo each other. And so we just get 5 there. So we get the square root of 2 times 5. And normally how we would write this is 5 square roots of 2. We kind of do it the same like we would an x here when we have a square root. We put the square root after the other number so that it doesn't get confusing. Okay, so that's how this gets really useful, is you can actually kind of simplify this. You have a smaller number now under the square root, and so it looks a little bit nicer. Okay, so I'll maybe show another example of this, of how this could be helpful. Notice we were able to simplify when there was a perfect square living inside of this number right here. So let's do another example. We'll do the cube root of 24. Okay, so the cube root of 24. Well, in this case, I'm dealing with a cube root, not a square root. So if there's any perfect cubes living inside of 24, we can kind of simplify this sum so that it's a little bit better. Well, what goes into 24? Let's kind of think of the factorization of 24. Well, 24 is 2 goes in there, right? 2 times 12, okay? And then if we kind of keep factoring out 12, right, what goes into 12? Well, let's see, 12, 2 and 6 go into 12. So we'll write the 12 as 2 times 6, okay? And then 2 is as simple as we can go there, but 6, does anything go into 6? Well, there is 2 and 3, right? Those are the things that go into 6. So this is as factored as it can get, right? Because the only thing that goes into 3 is itself and 1. The only thing that goes into 2 is itself and 1. So you can kind of see, oh, sorry, I missed my cube root there. You can kind of see there's 3 2's here. There's a perfect cube living inside of this 24 here. So we're doing the cube root of 2 cubed and 3, okay? And so what I can do is I can split this root into 2 separate pieces, do the cube root of 2 cubed, and then times the cube root of 3. Well, when I do a cube root of a 2 cubed, those are going to cancel out. The root and the cube cancel out, and we just get 2 cube roots of 3, okay? And so again, we were able to simplify because there was a perfect cube, a number cubed living inside of 24. And so we could simplify that. Okay? I'll just do one more example to kind of help us solidify this maybe a little bit more. We'll do one more, and then we'll move on to the next video. Running out of space, so I'm going to put up a new board for us. Let's do the fourth root of 32. Well, if I think of what numbers go into 32, I can kind of start factoring it out. Well, there's 2 and 16 go in there, right? And then I could factor 16 isn't prime. We could factor out a 2 from that, so we'll keep factoring stuff out. The 16 can turn into a 2 times 8, right? Well, let's keep factoring. We've got a 2 and a, well, the 8 we can write as a 2 and a 4, right? And then lastly, we can factor out so we had 3 2's here, and then this 4 we could write as 2 more 2's. Okay, so I'm just kind of finding the prime factorization of this number to see, well, this is a 4th root, so I'm looking for 4th powers of a number I can cancel out. Okay, so let's see, we've got a bunch of 2's here. In fact, we've got 1, 2, 3, 4, 5 2's. So altogether, if I can combine 4 of the 2's together, and then that can cancel out with the root. I'll combine 4 of those 2's together, and then I'll be left with 1 2 by itself, right? There will be 1 2 alone. So I took the 4 2's here, put them in here, and then there's 1 extra. Okay, so when you do a 4th root of a 4th power, those cancel out, and I just get 2 times the 4th root of 2. That would be our radical there. Okay, so hopefully this kind of helps jog your memory of simplifying radicals. I'm going to do some more examples in the next video where you actually have variables that will be similar to the homework problems. But hopefully this just kind of gives you a good review of radicals and the rules that you can use with them. Okay, I'll see you in the next video.